Okay, now we will yesterday we got to know what is functional interfaces, and we know what is lambda expression now. So quick recap: what is lambda expression? It is an anonymous function. And again, what is anonymous function? Okay, the function with no name, no modifier, and no return type. This is called as what? Anonymous function. So what are the actual benefits of lambda expressions? You can enable lambda expression for functional programming, and the code can be written in a readable, maintainable, and concise manner, right? So these are the benefits of lambda expressions, and we have seen these things already. So this is how you can, this is how the syntax of the lambda expression looks like. Okay, you have parameters, and this arrow token is very important, just like an ordinary method, but you don't have the access modifier, the return type, and the name. So everything is going to be same except for this, the arrow token, right? And parameters, array of this is not array operator, arrow operator. Okay, and you have the body, right? And we have also discussed about the functional interfaces. So whenever you hear the word functional interfaces, please remember in mind, please keep in mind SAM. Okay, so you can frame the sentences. Okay, what is SAM? SAM is an acronym for single abstract method, right? Any interface that has single abstract method, then it is called as functional interface. Only one line answer, right? What are the examples of functional interface? Okay, you have runnable interface, you have callable, you have comparable, and there are so many functional interfaces that are already there in Java. Okay, functional interface is not a new concept, it is already there in Java, but there are some changes made from Java 1.8 version, right? There are some huge amount of changes that has been made in Java 1.8 version. Okay, now so we got to know what is a functional interface in the previous session. Today we will see few examples. Okay, this will be very interesting. Please stay focused. I will help you with 5 to 6 examples so that this topic will be very much clear. So I want to write a Java program, okay, with and without lambda expression. So my first requirement, this is the first program. Actually, we have discussed one program, So we are going to discuss a few more examples. So without lambda expression, I want to write a program without lambda expression. Okay, so I want to deal with an interface. So let me write an interface. So the name of the interface is test. Okay, I want to take a functional interface. Always remember, always keep this as a programming practice. So whenever you are dealing with lambda expression, please annotate that interface with the functional interface annotation. Functional at the rate functional interface, so that this you can ensure that this interface is going to be a functional interface forever, and this can be utilized to invoke what lambda expressions. So I want to take a method here. So this time I want to keep the method as public. I want to take a return. I do not want to take a return type. Public abstract void. I'm passing two arguments. Okay, this is my actual requirement, guys. So interface always talks about your actual requirements. So this particular abstract method is talking about the actual requirement. Okay, this abstract method is designed. Okay, you are going to implement the interface, and you are going to provide the implementation, or this abstract method needs to be overridden. So this abstract method, okay, so if this is the method that is accepting two arguments, you are going to pass two arguments, and you're going to do what? You're going to do something for these values. Okay, so return type is there. If my requirement is I want to perform the addition of two numbers, okay, so let me keep the name of the method as add, right? The meaningful name I am keeping, and this method is accepting how many arguments? 2 arguments of integer type, right? You need to give the implementation. So this is a requirement. Okay, this abstract method is talking about the requirement and the inputs, but you will have to give the implementation. So to give the implementation, I am taking a class here, class driver. Okay, and I'm taking a main method, public static void main. So you can imagine, I'm just writing it in a short form. You can understand this, isn't it? Okay. So now if you observe the functional the interface and the class, they are separate entities. I want to give a connection between them. So if you want to give a connection between them, I need to use implements keyword. Okay, let me write this implements keyword in implements test. Okay, as soon as you start implementing an interface, when the class is implementing an interface, you need to also ensure that the abstract method is overridden. So you have only one abstract method. That abstract method needs to be, you need to provide the implementation. You need to provide the implementation for the abstract method. So what I can do, public void add. Okay, I need to write the logic for the abstract method by overriding it. Okay, so this is just the method declaration, and the moment you start overriding it, the moment you start implementing the interface by using a class, you should also do what? You should also override this abstract method. Overriding means you need to provide the logic, you need to provide the body for this abstract method. You need to provide the implementation for this abstract method. So my implementation logic is going to be very simple. I accept 2 inputs from the end user, and I'm going to do the addition a plus b. Depends upon the requirement, you write the logic. Okay. I'm taking, now my requirement is I want to add 2 numbers. I want to accept 2 inputs in the form of parameters. So I want to perform addition. So I am doing a plus b. Right? After doing this, so inside the main method, what I need to do? That inside the main method, I need to create the object, right? So you cannot create an object for the interface directly, so that I am keeping the interface. The name of the interface is test. I'm using the reference variable as t equal to new driver. You can create the object for the class. After doing this, by using the reference variable t dot add, and if I pass arguments as 100, 200. Okay, what output I will be getting in the console? In the console, I will be getting 300 as the output. 300 is going to be displayed on the console. Okay, so this is how the code looks like without using the lambda expression. Without lambda expression. Okay, I want to convert this code and I want to use the lambda expression. I want to utilize the functionalities of what lambda expression. Okay, what can I do? The same thing. Okay, I can keep the same thing here. Functional interface is going to be functional interface even with and without lambda expression. This is going to be same. No changes for this. Okay, and secondly, I am going to have the driver class. The class is also going to be same. Okay, and the main method is also going to be same. Okay, so with lambda expression, everything is going to be same. But here I want to be implementing test interface. So I will avoid this part. I will avoid this part here. I can remove this. I do not want to keep that. And also, I do not want to override the abstract method. This part can also be removed. Directly what I can do, directly I can create an object in the main method. Directly I can go to the main method. I can do what? I can use test t equal to. So instead of here I am using new driver, right? Here I am using new driver. Instead of creating an object, directly I can provide the implementation by using lambda expression, right? Directly I can convert this method to the lambda expression. How a method can be converted to a lambda expression? What I was just saying, right? Remove the access modifier, remove the return type, remove the method name, and what are the remaining things that we have? What are the remaining things that we have? So we have integer a comma integer b, right? These are the remaining things. And body, this body is also the remaining thing, right? So keep the body also system dot out dot println, right? A plus b, right? And what is the missing? So when you are writing a lambda expression along with the parameters, these parameters as well as the lambda, the body of the lambda expression should be separated by the arrow token, right? So I can do some optimization for this lambda expression. I can do some optimization for this. Is a complete lambda expression. Even if you keep this, it is okay, but you can also do some optimization. What is that optimization? So based upon the context, the compiler can able to guess the data type. So this data type is optional. I can remove this data type. First optimization, right? And if there is only one line, in the body of the lambda expression, I can remove this curly braces. I can remove the curly braces, right? So what are the remaining things that I have? I have the curly, within the parenthesis I have a comma b, arrow token, and this statement. Okay, I can put this in one line. Can do what? Can put this in one line. That's it. Then by using this reference variable t, okay, t is of test type. Okay, t is of what type? Test type. Okay, the control will go to the t is of test type. The control will go to the test interface and it will call. I mean, there is only one method in the test interface, which is add, and you do what? You call that method directly. Add. Okay, this add method is accepting two arguments. What are the arguments it is accepting? And any integer argument, you can pass any argument. Like I want to pass 10, 20. Right? The moment you call this method, the moment you call the add method, what is the logic that we have internally, right? So you are passing 10, 20. Okay, this 10, 20 will go as an integer argument, and the output is going to be what? 10 plus 20 is going to be 30, will be displayed on the console. We do that for the second time. T dot, you can pass a different argument second time. The second time I want to pass 1, 2. Output is going to be 3. Like this, you can call any number of times. The code remains concise, the code remains readable, right? And the code looks good, and you are reducing the number of lines of code. And the main thing is you are not using the implements keyword, and you are not overriding the method. So you are reducing the complexity, right? So this is without lambda expression, and this is with lambda expression. There are a lot of advantages that you are going to see forward, but understand the basic thing. Right? If you want to draft this code in the program, very simple. I will make it really quick. So interface test. Okay, what is the actual requirement? Public abstract void add. Okay, I want to pass two integer values here, integer a comma integer b. Okay, so you are giving the idea in the interface. In the interface, you are doing nothing. You are just giving the idea to the to the consumer. You are saying, okay, build a logic. So look at this. You are giving an idea. Okay, this interface is giving you the design details. It means you're going to build a functionality, or you're going to develop a functionality. Just understand that this is a functionality, and you are passing. You want to pass two inputs. You want to pass what? Two inputs. So let us pass two inputs here. Okay, what are the two inputs that you pass? So whenever you want to pass some inputs, the inputs can be passed in the parameters. You are passing two integers. You can pass any two integers, integer a comma integer b, right? And you need to get an output. What is the output that you need to get? You need to add these two integers. Okay, the output has to be what? Addition of two integers. Addition of what? Addition of two integers. Okay, so if you are passing 100 comma, if you are passing 200, you can write any kind of logic. It's up to you. Okay, this will go as an input. Always input will be taken in the parameters, right? This will go as an input, and this will go as an input, the second parameter. You can write any logic inside. Okay, this part, okay, the logic that you are going to write is the implementation method. Okay, so you're writing this logic in the form of lambda expression. You are converting the method directly to the lambda expression, and the logic is written. It's up to you. You can write any kind of logic, but the output should be what? Summation of two numbers. Okay, the actual requirement is given by the abstract method. Abstract method is saying, okay, this method is designed in such a way that it accepts two parameters. But my intention is those two inputs should be added, and the output is given in the form of what? The form of addition. Right, this is going to talk about the design, and you are going to do what? You are going to give justification for the design. So logic has to be written by you in the form of what? Lambda expression. So you can write any logic, but the output should not compromise. So you should write logic in such a way that it is not consuming huge amount of code, in a simple and concise manner. Right, what I have just written in our code, I was doing what? Summation 100 plus 200. Okay, it is going to be what? 300. Okay, 300 will be written in the console. What are the inputs that we are passing? One of the inputs is 100, second input is 200. Okay, so these inputs are talking about parameters. Okay, you pass this input in the parameters. Okay, this output is designed from where? This output is a part of the functionality that you are placing inside the lambda expression. Okay, so let's look at a second example for the better clarity. Okay, so this was the design. So if I am not using lambda expression, I need to do what? I need to do implements test. Okay, so what is the contract? Whenever a class is implementing the interface, the contract is what? You need to provide the functionality for the subtract method by overriding it, right? So public void add, and let me override this integer a comma integer b. So my requirement is accept two inputs, write a functionality. Our functionality is to do what? To do summation. Right, system dot out dot println a plus b. Right, the code without lambda expression. Right, and by using this interface, create a reference variable. I want to make sure that the reference variable is t itself equal to new driver. Okay, by using this reference variable t, I can call the add method, and I can pass two parameters, two inputs, 100 to 100. You can pass any inputs based upon the requirement. And if I run this code, I get the output 300. Like this, you can pass, call this method over and over again. Okay, second time I want to pass 1, 2. The third time I want to pass 1000, 200. So the output is going to be what? Summation of two inputs. Right? So this is without lambda expression. When I want to use lambda expression, I can remove this firstly. Okay, with lambda expressions, look at the code. I can remove this. I removed. Okay, let me remove. Let me give some space. I can also remove this. Remove. I am copying this and I am pasting it directly. Will it work? It will not work, because in the lambda expression, the access modifier is not required. I am removing that. The return type is not required. I am removing that, and also the name of the method is also not required. I am removing that. Okay, so body is required. and parameters are required, but they have to be separated by arrow token. I'm placing that, right? And I need to ensure that it is we are placing a semicolon at the end. Okay, this will work. If I run this code, definitely this will work. You're going to get the same output. But I have option to optimize this further. What is the first optimization that I can do? I can remove the data types, right? First optimization, still it will work, right? Further optimization, what I can do, if there is only one statement in the body of the lambda expression, I can remove this curly braces, not required. Okay. It works, right? I can place this in the one line. That's it. It will work. Hope we are getting this. So let us quickly discuss second example. Second example, my requirement is I want to pass a string. I want to pass some string. String can be, a sequence of characters is called a string. Okay, and the output should be what? This method should return me the length of the string. So my requirement is very simple, guys. My design requirement is, if I am passing Ratna, okay, if I pass Ratna as an input, I should get output as what? 5, because how many characters are there for the word Ratna? 5. And if I pass Ganesh as an input, okay, my output should be what? 6. If I pass Jyoti as an input, my output should be what? 6. It should return me the length of the string. If this is the design, I need to place my requirement in the interface, like the abstract method. So public abstract. So what is the output that I'm expecting? All the outputs are in the form of integers, yes or no? So public abstract. So return type should be integer, because I'm expecting output in the form of what? Integer type. Length is talking about integers, right? And what is the meaningful name that I can give? Meaningful name, right? Meaningful name is string length. Name of the method is string length. So something meaningful, isn't it? Right? What is the input that it is accepting? All the string values. So the input should be what? Input should be passed in the form of in the parameters. So I need to pass a string. I can give any variable name. Yes. So this is my requirement in the form of abstract method. Okay, I am placing this in the interface. I'm placing it in where? Interface. So public abstract. So return type is integer, right? And the name of the meaningful method name I can give, right? String length. Okay, it is accepting an integer. So without lambda expression, how we can do? Let me remove all this. Driver class needs to implement. Okay, after the implementation of the test interface, okay, what is the contract? I need to override this abstract method. Just copy this method and place it here, and remove the semicolon and give the body, right? Give the body, and what you want to do? You want to return integer, because it is expecting an integer. So you can the string that you are accepting here and give the length, right? And remove this abstract keyword. That's it. Overriding is successfully done, right? So this method is going to accept an integer, accept a string, and a logic is written inside. What is that logic? The string will be called on length method, so that the length of the string will be returned, right? So I am using this without lambda expression. Okay, so how to call this method? Use the test interface followed by any reference variable name equal to new driver. Okay, t dot, what is the method that we need to call? String length. Okay, this method is accepting what? Any string. You can pass any string here. Hi, hello, how are you? Okay, this has to return me what? Length of the string. So it is returning me something. If it is returning me something, I can use directly that in the print system.out.println statement. If I run this code, okay, I get 20, and if you count this, it will be 20, including spaces. Okay, and if I want to find the length of a particular string, let us say Venkatesh. Okay, it has to return me the length of the string. So this is how a logic can be designed without using lambda expression. If you want to use a lambda expression, keep few things in the mind. What is the first thing? Remove this implement test. Right? What is the second thing? Okay. Second thing is cut this method and paste it here. What is the third thing? Okay, remove the access modifier, remove the return type, remove the name of the method, right? And place a semicolon here. And place a what? Place a semicolon here, right? And after this, what you can do for the further optimization? What you can actually do for the further optimization? I mean, you need to place the arrow token, because this arrow token is very important. This is representing the lambda expression. What is the further optimization that you can do, right? So only one line of in the body of the lambda expression, there is only one line of code. So these curly braces are also optional, and if there is only one line of code, the return keyword is also optional, right? What is the further optimization that I can do? You can remove this return type, because based upon the context, the compiler can recognize the data type of the parameter. What is the further optimization that I can do? If there is only one parameter, okay, this parentheses are also optional, right? So this is the simple lambda expression. Simple lambda expression. So this is the code. And if I run this code, right, I get the same output, 2019. Okay, this is the second way of, this is how the lambda expression works like. Okay, you want me to help with any other example? Are you able to follow me, everyone? You want me to try another example? Any complex example, if you want me to try, I can try. Yes, no? Can we see few more examples? Able to follow? Yeah, okay, Krishna. What about others? Can we discuss few more examples on lambda expression? Okay, then we'll see few more examples. Okay, now I want to let us say that I have a requirement. Okay, and my requirement is actually like, and now you see, I will help you with a different lambda expression. Instead of string length, I am taking a method. Method is test method. Okay, and the return type is what? Boolean. Boolean, and the name of the method is what? EC1. Let's focus here. Okay, EC1. I want to accept an input in the form of number. Okay, so based upon the input, I want to return, if the number is even, I want to return true, right? If the number is not even, I want to return false. This is my actual requirement. So I have declared my requirement in the interface. So this is my interface. I have declared what? I have declared my requirement. So this abstract method, okay, inside the abstract method, inside the interface, I have placed an abstract method. This abstract method is just talking about the requirement. Okay, this part always talks about the input. This part always talks about the output. Right? This is the input, and this part, this part always talks about the input, and this part always talks about the output. Right? So what is the requirement? If I pass 100, I need to build a logic. I need to design a logic. Right? And in such a way that if I pass 100, so 100 is a number, isn't it? Okay. So inside the logic, inside this, I need to perform a logic in such a way that it is returning me either true or false. If the input is a even number, the output should be true. Okay, if the input is an odd number, something like 101, the output should be what? False. Now you have understood what is the purpose of abstract method. Abstract method always talking about the design, always talks about the expectations. It's up to the developer. You need to give the implementation. You need to write the logic, right? So we will start writing the logic for this, and let me remove all this. Okay, and I want to implement this. So without lambda expression, implements test, right? So what is a contract? So whenever you are implementing an interface, you need to do what? We need to provide the implementation for the abstract method. So I'm copying and pasting it. I'm just giving the body and I'm removing the abstract keyword, right? I need to write a logic. So what I need to write? If a percentage to double equal to 0, if the remainder is 0, I should return what? True, right? If the remainder is not 0, I should return what? False. This is the logic. This is a logic that I have drafted. Return false. Okay. This is a simple logic that I have drafted by using what? By overriding this abstract method. This is my requirement. This is how the logic looks like. Let me maximize this. Right, so logic has been written successfully, and I am using the main method. The main method I need to call, right? So what is the name of the interface? Test, right? Test is the name of the interface, and any reference variable t equal to new driver. Right, by using the reference variable t dot what? ec1. Okay, this ec1 is going to accept some parameters. Let me pass 101. Okay, I'm passing 101, and this 101 will be passed as a parameter to the method, and there is a logic inside, and it will return me either true or false. Right. So since it is returning me something, I can use that in the system.out.println statement, so that I can capture the value in the console. So 101 should be, is not an even number, so false. Right? If I pass 100, can you check if 100 is an even number or not? If it is even, we should get true. Right? If I want to convert this by using the lambda expression, very simple. Firstly, remove this implements keyword, right? And copy the method, and remove this new driver and paste it here. Okay, and add a semicolon. What are the three things that you need to do? You take care of removing the access modifier, need to take care of removing the return type not required. You need to take care of removing what? Removing the method name, right? And you need to place the arrow token or arrow operator. Okay, if you run this, this will work, no issues. If you run this, still you will get the answer true, because you have only one statement. Can I do further optimization for this code? Can you do any more optimization? So you are passing only one argument, so the return type can be removed. Post optimization, right? If I run this code, it will work. And since you have only one argument, this parentheses are also optional, right? And if you run this code, still it will work. Okay, but I cannot do anything on the, I cannot optimize anything on the body of the lambda expression, because if you have only one statement, you can remove, but there are multiple lines of code here, so this cannot be removed. So this is the most optimized lambda expression that you can get for this particular requirement, right? So you cannot remove this curly brace because there are more statements. Making sense? This is the third example, and we will see one more example on this lambda expression. So instead of taking, so this interface, okay, so we can also I forgot to mention this. You can also use this, no problem. If you are using this, you are not using this, but using this is an added advantage, so that the interface will remain as a functional interface forever, right? So these are the user defined interface, because this interface has been designed by the user, designed by us. So we design these interfaces. So I want to work with predefined interfaces. I want to work with what? Predefined interfaces. Focus here. This is very, very important. By this, we can conclude about the lambda expression and function interface. Okay, what is my requirement is, so there is an interface called runnable interface, guys. What is interface? Runnable interface. Okay, runnable. Okay, this interface is part of what? Multi-threading. In Java, there is a concept called multi-threading. We will discuss about the multi-threading going forward. I will keep it very simple. But there is interface called runnable interface, and that runnable interface is a what? Functional interface. So when I say functional interface, what does it really mean? So it means it has only one abstract method. Excuse me. Yes, it means it has only one abstract method. The abstract method is run method. Okay, it is part of java.lang package. Focus here. This is going to be very interesting. This is part of a package called java.lang package. Java.lang package. Okay, so this is already there in Java library. And what you want to do, you want to use this method by using the lambda expression. You want to utilize this method by using what? By using the lambda expression. So without lambda expression, how we can use? With lambda expression, how we can use? That we will understand first, right? Since it is a part of Java library, so in the Java library, just imagine this as a Java library. Inside this Java library, inside this package, lang package, java.lang package, lang.star. Okay, there is an interface called runnable. Okay, this runnable interface has a method, the abstract method called run method. Okay. Since it is already there in the java.lang package, you do not want to specify that once again. Directly you can write the code. So let me write the code class driver class. Okay, I am writing the code without using the lambda expression. So I need to what? I need to implement this runnable interface. Implements runnable, right? Public static void main. And so whenever you are implementing an interface, whenever a class implements interface, what is the rule? You need to give the implementation for the abstract method. So let us override this abstract method, public abstract void run. Okay, you need to, this is not necessary. Okay, you need to write a logic inside. System.out.println. Okay, and I'm writing something here. Don't worry what is being written here. Overriding as done. And what you want to do after overriding this, you need to runnable obj equal to new driver, because reference variable should be of interface type and you are creating an object for the driver class, right? And so you are going to create a new thread. Don't worry about this code, I will explain you. Thread t equal to new thread, and you will pass this obj here, right? And you will call t.start. Okay, what is the purpose of this multi-threading is, usually we know that there is a thread called main thread. Okay, the main thread starts executing from the main method. So this is the main method, right? And it finds the first instruction. What is the first instruction? And object is getting created, and that object is getting stored in the reference variable of our runnable interface. And here the second line says thread t equal to new thread. Okay, again, okay, this thread is going to create a child thread. What does it mean? Along with the main thread, a new thread will also born. Along with this main thread, a new thread will also born, right? So this is going to give birth to the new thread. When you say thread t equal to new thread, it means it is creating a new thread. Already there is a thread called main thread. Main thread, the purpose of main thread is to do what? It executes all the instructions inside the main method. The moment you give thread t equal to new thread, okay, this thread will give a birth to the child thread. The job of the child thread is to execute all the instructions inside the run method. So now there are two threads. These two threads operates parallelly to save some time. So this is the simple background, right? So if you want to understand this better, what I'm trying to do, I'm implementing the runnable interface, right? So the moment you implement the runnable interface, you need to override the unimplemented methods. So public void run. Here I am doing what? I want to write some logic here for integer I equal to 0, I is lesser than 10, I plus plus, system dot out dot println child thread. Don't get distracted. You will understand this. Focus here. Okay. So this run method is part of the runnable interface. So I'm just overriding it. So inside this, I'm creating a for loop. I want to execute this child thread for 10 times. Why I'm doing this, you will understand this. Why I'm doing this, you will understand this in a short period of time. And then what I'm trying to do, I'm creating an object with the runnable interface reference. Runnable r equal to new driver. Okay, runnable r equal new driver, and I am creating a thread class, thread t1 equal to new thread. Okay, I am passing this r as an argument. I'm doing t1 dot start. T1 dot start means the control will travel to the run method. The new thread will travel to the run method, and here I am keeping some statements. Copying this, I am pasting it here. Right, this is main thread. If I run this code, you will see something that is happening behind the scenes. Okay, you are getting main thread, child thread, child thread, child thread, child thread, child thread. And if you see, first 3 times you are getting main thread, then you are getting child thread, child thread, child thread. Again, you are getting main thread, main thread. What is happening because of this piece of code? We will understand this now. Let me open the new slide screen. Okay. So far till today, we have been discussing about only one thread, which is what the main thread. Only one thread. We know what is that one thread. That one thread is what? The main thread. Main thread. So what is the purpose of main thread? Main thread will always get access to what? Get access to the main method, and it will execute all the instructions that is placed inside the main method. So it will come to the main method. So it has found the main method. So what is the first instruction? It has noticed an interface called runnable interface. Okay, right? And then it has noticed the thread class. Okay, the combination of runnable interface and the combination of thread class. And it has also noticed it is going to do what? This main thread is going to create a child thread. As soon as it encounters this thread instruction, it is going to create another thread called what? The child thread. Okay, till here there will be only one thread, guys. After this, 2 threads will be created. Okay, the name of the thread is, one thread is going to be remain as main thread. Okay, the second thread is going to be remain going to be, the new thread is going to be what? Child thread. Okay, main thread and child thread, right? So 2 thread will be created. So let us keep it as what? Main thread m. Let us keep it as what? Child thread C. Okay. And the moment this child thread encounters the start method, okay, the control will directly jump to child thread will take care of all the instructions that is placed inside the run method. Okay, the responsibility of child thread is to execute all the instructions that is placed inside the run method. The responsibility of the main thread is to execute the remaining instructions that is there in the main method. As simple as that. So these two threads are going to execute the instructions parallelly. Okay, main thread will take care of all the instructions that is there in the main method, but the child thread will take care of the instructions that is there inside the run method. If this happens parallelly. Okay, so child thread at the time of executing this instruction, child thread is going to execute this the instructions that is there here. Okay, and this will also execute the instruction that is there here. Parallelly it will happen. Simultaneously it will happen. Parallelly it will happen. Right, that's why you are getting the output in the console as what? In a different order. You cannot expect which will execute first, which will execute last. First three instructions are main thread and the remaining are child thread, and again main thread is coming in the picture. If you run this for the second time, depends upon the operating system. First all the instructions are from main thread, then the instructions are from child thread. If you execute this for the third time, you see the order is getting changed. First two instructions are from main thread, then child thread is coming in the picture, then main thread. Okay, it depends upon the operating system. It varies from system to system, so you cannot guarantee which statement executes first. This is a concept of one of the concepts of multi-threading. You forget about multi-threading, just try to understand the execution of functional interface and invocation of lambda expressions. Okay, if you want to convert this piece of code into the lambda expression, what I can do it here, right? So here new driver. Okay, I can remove this. I can remove this runnable interface. Okay, and the overriding method, this is an overridden method, so I can remove this. I can place it directly. 1 minute. I can remove this. I can place it directly here, right? And semicolon is required. Okay, and the return access modifier is not required, return type is not required, name of the method is also not required, right? I need to just place an arrow token between the parentheses and the body of the lambda expression. So that's it. The reason why I'm telling this is, even you can convert the inbuilt interfaces, the existing interfaces or the predefined interfaces to the lambda expressions. So this is how the equivalent lambda expression for this particular class, for this particular program, right? Since there are many statements in the body of the lambda expressions, you cannot optimize this further. Okay, still if you run this code, the output that you got without lambda expression, the same output you are going to get when the functionality is going to be remains. Okay, just don't worry about this multi-threading concept, just think about how the conversion is happening. That's it. Okay, this multi-threading concept will be discussed shortly. Just think about the conversion of non-lambda expression to the lambda expression. How you can write a code without run with lambda expression. That's it. That's the agenda of this class. That's it. Right. If you have any questions for me, you can ask. Are we good? Shall we wind up for the day?